Good day, everyone. You are welcome to today's lesson. And in today's lesson, we are going to look at the continuation of the topic on trig, just as you have on your screen. Today's lesson basically will be looking at worked example where we have to apply all the concepts that we've learned so far in lessons 1 up to lesson 3. So today's lesson is going to be lesson 4, which invariably I'm trying to say that we are going to apply all that we've learned so far. All right. Okay, so just as you have on your screens, okay, the first worked example for today's lesson or today's class, okay, you can see, please, what I have here, is it clear? Can you see? I'm still going to read anyway, but can you see? Is it clear?
Yes, please.
Okay, so in the diagram, ADC is a straight line. So ADC, this is a straight line. Okay, and we are told that the length of CD is 48 centimeters. So this length, okay, is 48. The length of BD is 36 centimeters. So this length is 36 centimeters. And the length of AD is Y was centimeters. So this length here is Y centimeters. Okay, and if you look at the figure clearly, you can see that there is a certain information in this figure that is not stated in statement form here. And that information is that you can see that this information here is trying to tell us that the angle here is 90. Therefore, because this is a straight line, this angle here will equally be 90. Do you agree with me? So angle ADB is 90 and angle BDC is also 90. Do you agree? My professors, are you with me?
Yes, please.
Okay, so respond in quick time. We have a lot to do. Then again, you can also see that, okay, there is this angle, the nature of this angle, you can determine that it is also 90 based on what you have here. So this time around, it is the entire angle ABC that is 90 degrees. Not only this angle, not only this angle. Okay, the entire angle here. So please take note. Okay, so remember the advice, okay, is that anytime you are given a composite figure and you are going to use the composite figure to solve question, always break it down. Break the composite figure into simple figures that you can easily work on. So that's exactly what I'm also going to do. So I'm going to go by that same advice. So this is what I'm going to do. Let's see. Okay. How I can pick. Okay, so let me go for shapes. Okay, all right. So at this point, let's see what we are going to get. Oops. Okay. All right. So this is what we have. If you look at this figure, how many right angle triangles can you get from this figure? How many can you see? Or do you see from this figure? How many do you see? Just tell me how many triangles you can see. How many, my professors?
2.
2. Okay, you can see 2. Do you agree that we are going to get only 2 right angle triangles? 3. You can see 3. Okay, in fact, there will be 3 right angle triangles. So if you said 2, no issues, you are able to see 2. So very soon you know where the other one is coming from. Okay, so we are going to get 3, and that will be this small one that you have here, which is a right angle triangle. That is right angle triangle ABD. Then we also have a right angle triangle BDC, and the bigger right angle triangle, which is the ABC. Do you all agree now?
Yes, please.
So I am going to draw these 3 right angle triangles. Oh, what happened? Okay, so I picked I think it went back to, so let me draw my, okay, what do you call it? So my first right angle triangle, okay, then let me draw maybe the orientation will not be the same, okay, but it will be right angle triangle. So the second right angle, I'll come and label the vertices. Now we know that we have 3. So let me draw the 3 right angle triangles there. Okay, then we come and deal with all that we have there. Okay, so let me, oops. Okay, then, okay, the third one. Okay, so these are the right angle triangles that we are going to get. So let me move on to, okay, my pen, then we'll label, okay, the vertices. Okay, so we know the bigger, I'm going to indicate the bigger one first. The bigger one is A, B, or C. So this is what you do. In terms of triangle, this, you know, this will be your 90, so your 90, oops, forgive me, your 90. Okay, this will also be 90. This will be 90. So you indicate its nature. Okay, however, okay, when you are labeling the vertices, this is what you do. First of all, label, okay, the 90 degrees vectors. And the angle, if I'm looking at a triangle ABC, my bigger triangle, the angle 90 is at the vertex B. Oh, yes, so that will give me B. So I put B here. After that, the other 2 points, you can put them anyhow or label them anyhow. So I can call this maybe C, then this A, or A, then what C. So I am going to call this A, okay, and this C. My professors, I hope you are following.
Yes, please.
Okay, the same thing. If I come to this right angle, you can see that the orientation is not the same as this. This one is moving in this direction. I mean, you can see that this one, okay, it's like it's the orientation is rotated in this direction, but it's still 90. Now, what do I do? Okay, I indicate my 9. It's 90 at D. So this will be D. Okay, and I'm looking at triangle ABD. So once I fix my 90, the other two vertices can be labeled anyhow. So let me see if I can label this my B, then this my D. I hope you are following my professors.
Mr. Akon, please, you've made a mistake. This is supposed to be A.
Where is it?
The
Oh,
other angle.
let me see. Okay, it's A, B, forgive me. So this is A, not D. Okay, all right. So it means you are following. All right, then let's come to the third one. The third one is this particular one. Okay, so that would be angle, a triangle BDC. So triangle BDC, it is right at D again. Okay, however, I'm looking at BC, so maybe this will be B, then this will be C. Okay, so we are fine now, right?
Yes,
Okay,
please.
so now what you go and do is go and fix the information that you can get from the other information that you can add to each of the triangle. So if I come to the bigger triangle here, okay, I know that the length here is y, the length here is 48. So the length of AC will be y plus 48. Do you agree?
Yes, please.
Okay, so y plus 48. Okay, centimeters. Let me indicate, okay, centimeters there so that you know. Okay, then which other side of the triangle ABC do we know again? I think that's the only side. Do you agree?
Yes, please.
Okay, so we move on to the next triangle, which is triangle ADB. ADB. So that will give us what? We know AD. AD is what? Y. So we know that this is Y. Okay, and we also know BD. And BD, we are told, is what? 36 from that. I hope you are following.
Yes, please.
Okay, then we come to the last one. The last one, we know a DC. And where is DC? DC is here, so that was 48 cm. Okay, and we also know BD. And BD, we know is what? 36. My professors, I hope you are following.
Yes, please.
Okay, it is 36 centimeters. Okay, so, okay, these three triangles that you have there, which one do you think you have more information to work on or to work with? First, second, third. First,
Third.
second, third, the third. So, like I told you, once you split, go, okay, to your focus should be on the triangle that has more meat, okay, to chew. So if I go to this triangle, I know that I can use Pythagoras theorem to find BC. So what's your plan? You are supposed to find Y. That is AD. Okay, so if I'm able to find BC, obviously I can see that there is BC also here. Do you agree?
Yes, please.
Okay, so I would have found what's this BC. And okay, so let's proceed. I will guide you as to what to do next. So the basic information, let's come and work on this. So we are going to use Pythagoras theorem to find BC. So I'll come and write by the Pythagoras theorem. Okay, so we appreciate, okay, our anchor by the Pythagoras theorem. And remember, I've told you it's capital P. My professors, I hope you are following.
Yes, please.
Yes,
Okay,
please.
and it's the apostrophe comes after the S. Okay, take note. Our BC square, so the length of BC squared should be equal to, because BC is the hypotenuse, it should be equal to 36 squared plus what? Help me, let's go together. We are doing this together. 36 squared
Plus
plus
48 squared.
48
48
squared. Okay, so squared. You can ignore the unit now. Later, when you find your result, then you attach the unit. Is that clear?
Yes, please.
Okay, so it means our BC, I want to avoid repetition. So otherwise it would have been BC squared. So I will write equal to here. So 36 squared will give us, my professor.
1296.
1296.
Okay, so 1296. Okay, then plus 48 squared.
2304.
Okay, 2304. Okay, so 304. Okay, all right. So now let's sum that and see what we are going to get.
Please, 3600.
3600.
Okay, so 3600. Okay, so that is our BC squared. But remember, we are not looking for BC squared. We are rather looking for what? BC. So it means we have to come and take the square root of both sides. All correct?
Yes, please.
Okay, so now I will say that this implies that, okay, my BC, oops, okay, will be equal to root of this side. So that is 3600. I hope you are following, my professors.
Yes,
Okay,
please.
which will give us BC to be equal to what? Okay, here 60.
60.
Okay, so don't forget your CM, your unit. So you found BC. You can see that I didn't write there for BC because I was not asked directly to find BC. BC is only a means to an end. So I cannot conclude with it. All correct?
Yes, please.
Okay, then once I know BC, let's go. So it means I know this to be what? To be 36. Sorry, 60, forgive me. This to be 60. Okay, so now this is what you need to do. This is again a certain advice that you should always have at the back of your mind. Please make sure you go by this advice. If you now you've worked on this, you know that this is 60. Let me also indicate the 60 here. It didn't come, you have found it. Okay, so after working on this, now you can see that these two triangles that you have here, this one you don't have to do anything to it. All that you can do is what you have done. Now you come to the other two triangles. The other two triangles that you have there, okay, it means now your focus is going to shift from the third triangle to the first two triangles. Okay, so these two triangles that I have here, basically I can see that indirectly they all have the same information or the same meat to work on. Okay, because this triangle has two sides given. This also has two sides. But the two sides, one of them is exact side and one involves what? A variable. So this involves the variable y, okay, and this is what do you call it? 60, exact. This involved y, and this is what? Exact. So the two triangles, they have basically the same information or materials, okay, to work with. However, this is what you do. Go and look at the two triangles. Check whether they have a common side. If they have a common side, it means you are supposed to form an equation to link these two common sides. Okay, by that, this is what I mean. If you look at the triangle here, okay, as a rough work, we are going to, if you look at this triangle, triangle ABC, the side that you consider in triangle ABC will be side AB, and give me the other side AC, am I right?
Yes.
And which side?
CA. AC.
AC. AC, I've written AC.
BC.
BC. Do you
BC.
agree?
Yes, please.
Okay, now let's come to triangle BDA. Triangle BDA, what will be the size? You can get AB.
BD.
BD, AD. Okay, I want us to move alphabetically. Other than that, DA is the same as AD anyway, so no issues. Okay, so if you look at the size that you have here, which side do you think, okay, you have in both triangles?
AB.
AB. Okay, so this one, if you are matured, you wouldn't do this. You do it mentally. So you can see that this has AB, this also has AB. Okay, so the common side is what? Is the AB. So what you are going to do is you are going to take this triangle, use Pythagoras theorem to create an equation involving AB. Then come and take this triangle, okay, create an equation involving AB. But because the AB here should be equal to the AB here, it means in effect we can equate the two and solve. By that, this is what I mean. Okay, Prof. Gideon. Okay, and you know if the issue is about your if the issue is about your internet connection, I've told you, unfortunately, I wouldn't be able to go back. You know the rule. So what I will do is that's why we share the video. So when you get the video, okay, you try to go back and see if you can relate. However, for now, what you need to do is now that maybe your internet is better, okay, try and see if you can follow through. Otherwise, when you get the video, then okay, you deal with that issue. Other than that, wouldn't be able to move. Thanks for your understanding. All right, so at this point, I'll come and write from, okay, I'm going to pick one of the triangles. Okay, and even with this one, I think I should have started with that. When I was going to work on the Pythagoras theorem, remember I've told you, immediately you split. Let us know which triangle you are going to work with. So I should have written here from, okay, triangle BDC, before coming to write this. So please take note. So when you are doing your presentation, do that. So I'm going to do the correction from here. So from my first triangle that I have here, okay, right angle triangle, okay, ABC. Okay, I'm going to apply the Pythagoras theorem, but I will write by the Pythagoras theorem again because I've already stated it up here, remember. You state it only once in one question. Okay, so now, what will be my hypotenuse in this triangle? It's AC, is that not it? My professors, are you with me? It's AC, do you agree?
Yes, please.
Okay, so it means my AC, which is y plus 48 squared, okay, should be equal to, now it should be equal to, okay, AB squared, do you agree? You don't know the length of AB, so AB squared, then plus the other side, which is 60 squared, do you agree? My professors, are you with me?
Yes, please.
Okay, so what we are going to do is let's expand the side because we can expand the side. So it's like we are going to simplify each of the terms that could be simplified. So if you are going to simplify this, we know how to expand this. So I'm going to rely on you. This will give us y squared, okay, plus twice the product of what? Y and 48. So that will give us 96y. Am I right? My professors, I hope you are following.
Yes, please.
Then plus 48 squared. 48 squared will give us, remember you've done it here. And that's it. Okay, we've done it here. So it will be 2304. I hope you are following, my professors.
Yes, please.
Okay, and that should be equal to your AB squared, the length of AB squared, then plus 60 squared. 60 squared, you also know. That will give us what? 3600. Okay, so 3600. Okay, so remember the goal was to, okay, get an equation in terms of AB. So I'm going to make the AB squared stand alone. So in that case, I have to move this one to this side. Is that clear?
Yes, please.
So though I'm moving this one here, in my mind, okay, I'm going to write the AB squared and move that one first. So I'll write AB squared, the length of AB squared, okay, should be equal to, y squared, okay, plus 96y, okay, then plus, no, I think it will be minus instead. So I'm going to do 2304 minus 3600. I'm waiting. I hope you get the point. This one will come here. So let's do, you don't have to come and write plus, minus before you come and write its value. Your next step, you can do subtract mentally, add mentally. So let's do that. 2304 minus 3600. Oh, my professor
Negative
said
1,296.
1,000.
Negative 1,296.
Okay, 1,296.
Yes, please.
Is that not it?
Yes, please.
Okay, so that is the AB squared. And here, someone will say, maybe let me come and take the square root of that so that I'll get AB. I will advise, don't take the square root. So you can still work with the AB squared, because this one too, you can still get your AB squared or your AB in terms of squared, and you come and equate. So I'm going to call this equation 1. Okay, then go to the second triangle. So from, okay, our second triangle, and that is triangle, right angle triangle, BDA. I hope you are following my professors.
Yes, please.
Okay, again, using the Pythagoras theorem, we are going to get what will be the hypotenuse, okay, of this triangle.
AB.
What is the hypotenuse? AB. So I will say that the hypotenuse, which is the AB squared, okay, should be equal to 36 squared plus y squared. Do you agree?
Yes, please.
Okay, so on that note, what do I get? I'm going to get, okay, AB squared here to be equal to 36 squared, we know will give us
3,600.
Okay, so you are going to get what? 36 squared will give you 1296. Do you agree?
Yes.
Okay, so it will
Yes,
give you
correct.
1296 plus y squared. Okay, so that is your AB squared. So I will call this, okay, my equation 2. But you can see that this AB squared here of your first triangle and the AB squared of your second triangle is the same length AB. So if you square it, it should be the same. So it means equation 1 must be equal to equation 2. Do you agree?
Yes, please.
Okay, so on that note, I can write, this implies that, okay, or I can write, before I come to the imply, let me write, okay, this, okay, equation 1 is it's equal to equation 2 straight away. Okay, that doesn't mean if you write implies, okay, you are wrong. But it's better you wrote either but or you ignore. So I'll write equation 1 is equal to equation 2. So if equation 1 is equal to equation 2, then it means that this expression here should be equal to this expression. Do you agree?
Yes, please.
My professors, your voices are down. Are you sure you are following?
Yes, please.
Yeah.
Okay, great. So we are going to get what? Y squared plus 96y, okay, minus 1296 should be equal to, okay, 1296 plus y squared. Do you agree? Hello, do you agree? Remember, I've told you that this will always be too short to take a line. So bring comma, semicolon, colon, okay, separate before you come and attach. So I know that the y squared and the y squared here will cancel, because if I move, I'm going to get y squared minus y squared. So that will go. Okay, then I'll get 96y. So I'm going to write, this implies that, okay, 96y, okay, then I will move this one to, because I am making y the subject. Someone can bring it here before taking it back, but I will know that it will give me an equation in y once y squared goes, a linear equation. So I'll rather move this one to this side, and that will give us Uh-huh. 1296 plus 1296. That's 1296 times 2.
2,592.
Okay,
592.
2592. Please, do you all agree?
Yes, please.
Okay, so now at this point, you are looking for y. That's your goal. So you write it again before you divide. Okay, over 96. Over 96. So I'm waiting for your answer. So
27.
27.
okay, so y will be equal to 27. So I know that I found y. So I can come and write therefore y is equal to 27, but I don't end there. I should have the unit and it will be 27 centimeters. Simple.
Yes, please.
All correct.
Yes, please.
Okay, so now the basic, okay, Prof. Angie, let me land, okay, then I'll call you. Okay, now the basic advice from this is that anytime you split, okay, work on the figure with most material or with more material. Then after that, okay, if possible, form an equation linking to, okay, common size and solve the resultant equation for any unknown that could be solved for. Okay, so basically, this will be the point that you are supposed to pick from, okay, what I've said, okay, so far, the major point. Okay, Prof. Angie.
So please, my question is, can the sine rule be used for right angle triangles as well?
Sine rule.
Yes, please.
Okay, in fact, that question was addressed in that lesson. In fact, when the figure is a right angle triangle, okay, you don't use the sine rule or the cosine rule, use the trig ratios.
So it doesn't apply to right angle
No,
triangles?
that's a special situation. If your triangle is a right angle triangle, then it moves to that special, okay, form of dealing with it, which will be the trig ratios. But if it's not a right angle triangle, that's when you use the sine rule and the cosine rule, depending on which one will be suitable. Okay, based on the information you have in that right angle triangle. So if it's a right angle triangle, use Pythagoras theorem, the trig ratios. Otherwise, you use what the sine and the cosine rule. Are you with me?
Yes, sir. Thank you.
Okay, so I
Yes,
want to say
please.
something here. Maybe you can relate very well. Let's quote the, what do you call it? The sine rule. The sine rule, if I have a squared, okay, assuming I have a squared, I know will be equal to b squared, the cosine rule, forgive me, okay, plus c squared, let's go, minus twice, okay, bc, then cos your angle. Is that not it?
Yes.
Okay, so let me say my angle at A. If the angle at A is 0, cos 90 will give you what? Sorry, if your angle at A is 90, that's a special situation, a right angle triangle. Cos 90 will give us what? If A is 90, what will be cos 90?
No.
It will cos 90 we all know is, no, cos 90 we all know is 0.
Yes.
You know, it's everyday language. This is cos 90. Okay, so if cos 90 is 0, it means the whole of this will be 0. Do you agree?
Yes.
Okay, so if the whole of this is 0, what is left? What does it, okay, what bell does it ring?
Pythagoras theorem.
Pythagoras theorem. So if it is 90, don't go and quote this long one because it will end up giving you this. That's basically, okay, what you need to know. Do you get the point now? So special situation demands special way of dealing with it. My professor, is my point well made?
Yes, please.
Okay, so that was just
Yes.
by the by. So let me go and clear this quickly. Okay, let me clear this because I wouldn't need this. Oops, I wasn't taking the whole of that. So let me clear the whole of this. Oops, what is happening? Oh, this one I'm not using the annotation, so this should go. I should rather use the eraser from here. Forgive me. Okay, so I'm using the PowerPoint. Okay, so oops, forgive me. Eraser. Okay, so let me pick the eraser from here. So it should go. Okay. Any questions at this point? Is the explanation okay to each and every one of you?
Yes, please.
Okay, great. Okay, so now that was just by the way. So let me clear it. It's not part of this solution. It was just an answer to. Okay, so I can go back to my pen. Okay, so let's see. So now let's look at the next question. Okay, so the next question, oops. Okay, at least let me see. Only the maybe the diagram didn't go. So that was the disadvantage of using the annotation there. Okay, if you don't clear it, then all the pages you see it. Okay, there. So let me see if I can come and clear this one. Okay, so first of all, so solution. The other one, did I write the question number? No, I didn't. So it means I'm doomed. So solution to question number 1. I hope you agree with me.
Yes, please.
Okay, questions are not made because we want you to. So solution to question number 2. So with this one too, let's see. Okay, how many right angle triangle can you get from this based on the information given? No assumptions. How many? My professors, let's go. How many?
3.
3.
3, okay. Are you sure? It will be 2. Okay, it will be this one and this one. Now you cannot say that this is 90. Do you agree? Because there is
Yes,
no
please.
information, so you cannot assume. That's why I told you no assumptions. Okay, so if you are going to get 2, then it means 1 must go from here. So let me see if I can delete this, if this can go. Oops, okay, so it can go. So that I'll rely on that. Okay, so in my subsequent pages, then I will clear. So at least, though initially I thought it was a mistake, which would have been, but it has served a good purpose. So I'm going to deal with it. So let's go and label, our right angle triangle. So, let me pick the pen from here. Usually this one right there. Okay, so the first right angle triangle will be, where YMX. So where it is right will be M. So I indicate 90 here, and this is M. Okay, and the other 2, I can put them anyhow. So X and Y. Let me put X here, then Y here. Okay, someone can put Y here, X here. It's the same thing. Okay, then we come to the other right angle triangle. If this is 90, this will also be 90. Okay, so you don't need a rocket scientist to tell you that. So now I'm coming to deal with this. Okay, so that will give me MXZ. So the triangle is still right at M for this particular one. Okay, and the other 2 sides or vertices will be, I should say, X, Z. So let me put X here again, then Z. All correct, my professors.
Yes, please.
Yes,
Okay,
please.
so now, that I have been able to split, let me go and I give the additional information, attach it to my diagrams. So here I'm told that YM is what? Is, what do you call it? 5 centimeters. So this is 5 cm. Okay, then what else? XY, I'm told, is 13 centimeters, so 13 cm. Okay, I'm done with this particular one. Let me come to this. This one, the only side that I know is what? XZ. So XZ here, I'm told, or we are told, is
15
centimeters.
centimeters.
All correct. So now we've been able to attach all the possible information that could be attached. Is that clear?
Yes, please.
Okay, so
Yes, please.
remember, the advice is to go and work on. So what is the question even asking us to find? So we are supposed to find the length of Y, Z. So we are finding the length of Y, Z. So the length of YZ we know will be YM length plus what? MZ length. Do you agree?
Yes, please.
Yes,
So it
please.
means if I'm able to find MZ length, then I know YZ because I will add this one to this. So MZ, I don't know. So let me represent that one by maybe X. Is that clear? Small
Yes,
x.
please.
So this is what I have. So I come here from this time round, I'm going to do the right thing from the beginning. So from which triangle do you think we should work on first, based on the advice that you've been given?
The
First
first one.
first triangle? Because, why did you go for that one? Because, hello, my professors, because,
Most
please
of the
pardon.
sites are known.
oh no, because
Most
more,
of the sites are known.
yes, you know it because that one has more materials to work with or more meat to chew. You get it? All right, okay, so now let's go. So from right angle triangle, okay, so right angle triangle, XMY, okay, Y. Okay, by the Pythagoras theorem, we are going to get, so let's go by, oops, my Y is, but in any case, the Pythagoras theorem. So I won't write it. So you know you are supposed to write it just to save time. Is that clear?
Yes, please.
Okay, then, so our hypotenuse will be 13. So we are going to get 13 squared should be equal to what? Okay, your XM or MX, the length
Right.
of that one, okay, squared. Okay, then plus what? 5 squared. Do you agree?
5. Yes, please.
Okay, so
Yes, please.
here we can find MX. So what do we do? I'm going to write, so let me simplify. What 13 squared will give us 169.
Yes, please.
Should be equal to my MX.
Right.
And you can see that I'm using capital letters throughout in terms of my vertices. Okay, points are indicated by capital letters. So if you put small letters there, you are doomed. Then plus 25. Do you agree?
Yes, please.
So my
Yes, please.
MX squared will be equal to 169 minus 25. So I'm going to write it. Okay, MX, okay, squared should be equal to 169 minus 25 will give us
144.
144.
144.
Okay, so it means my MX will be when I take the square root of both sides. Do you agree? Okay,
Yes.
will be
Yes.
equal to root of what? 144. And you can see that I took only the positive square root because I know that I'm dealing with length, and length cannot be negative. Okay, so I will say this implies that my MX length, okay, what I'm looking for will be equal to, I can choose not to even write this and come and write the equal to. This simply understood to be there. And that will give us 12. All correct.
Yes, please.
Okay, then don't forget to attach your units. The units that you have there is centimeters. Afa.
Yes,
Yes,
please.
please.
Okay, but MX, no, it's only a means to an end. Okay, so if I know MX, okay, then I'll be able to find MZ and therefore be able to find Y or Z. So that was the goal. Okay, so in that case, what do? I cannot come and write therefore here. So I go to my next triangle from which triangle? Right angle triangle. Okay, XMZ. Do you agree?
Yes, please.
Okay. XMZ, what are we going to get? By the Pythagoras theorem, but you don't write it again because I tell you that, okay, stated it up here. Let's go ahead, make use of the theorem. So I'm going to get what? My hypotenuse in that triangle is what? It's XM, am I right?
Sir, please, the hypotenuse.
It's XM, am I right?
No.
Please.
No, what is the
It's
hypotenuse? XZ. Okay, so you know
Exit.
a side opposite the 90. Immediately you switch any of them, okay, you are wrong. So that will be, we know its value. So 15 squared, okay, then must be equal to
equal to
XM squared. Okay, so let's write it XM. We'll later come and put its value there, don't worry. Okay, so XM squared, originally you don't know from that triangle. Then plus what? Okay,
MZ.
MZ, okay,
MZ.
squared. Very good. You are doing well. Keep it up. MZ, okay, squared. Okay, so now I'm going to get what? 15 squared
15 squared
will be
is
equal to, I know XM now. What is XM?
12.
12. So 12 squared.
12
Then
squared.
plus, okay, my MZ,
squared.
okay, squared. Okay, so at this point, what do? I make mz squared the subject. So my mz squared, I'm writing it here. That doesn't mean I have moved. Okay, so mz squared will be equal to, so I maintain it, I'm moving this one, but I'll write their corresponding values. So 15 squared will give us
225.
225, then minus 144. Do you agree?
144. Yes, please.
Yes, please.
Okay, so our MZ, okay, will be equal to 225 minus 144.
81.
81. Okay, but that is MZ squared. So I'll write this implies that my MZ without the square will be when I take the square root of both sides. Okay, so MZ, and that will be
9.
equal to root of what? 81. Okay,
Yes,
so that will be equal to what?
9.
Oh, I wrote 91. Okay, so 9. And don't forget your unit. We know the unit, and that will be CM. Is that clear?
Yes, please.
Yes,
Were we
please.
asked to find MZ directly?
No.
No,
It's
please.
only
No,
a means
please.
to an end, so you cannot write therefore. So now that you know, so I can come and say, therefore, what I was asked to find, what was I asked to find? The length of what?
Length of
YZ.
Y and Z.
Okay. Okay, so YZ. And that I know is equal to
YM
YM. Very good. The length of YM. Okay, plus the length of what? MZ. Very good. MZ. Okay, so this will be equal to, what is YM? Okay, we found,
YM is 5.
okay, fine, that one was
centimeters.
given 5 centimeters. You can ignore the unit. Plus, okay, your MZ that you have found.
Yes, please. It's
9.
9.
Okay, so that will give us
14
and you don't forget to
14
attach your unit.
centimeters.
Okay, and that is
centimeters.
what? Centimeters. Safa.
Yes, please.
Yes,
Okay,
please.
very good. Any questions at this point before we move on?
No, please.
Okay, you are fine. Okay, great. Let's see one question. Okay, more. Okay, so wait, that's one. So let's go and look at what this particular question. Okay, which will involve the use of trig. Okay, because of the
Oh my
information
God.
that you have. Oh, who was that? Okay, so that's good. Okay, so I hope we can start the question 3.
Yes,
Yes,
please.
please.
Okay, great. Okay, so let's look at the figure that we have. And usually, the information that you have there, will tally with the information that you have in your, figure. Only that sometimes there will be information in the figure that will not be up here, or in this statement that will not be in the figure. So you can just attach, them as you need them in the figure. All right, or make use of them. All right, so now let's see, in this triangle 2, how many, in this figure, I should say, how many right angle triangles can you get?
2.
Yes, please. 2.
2. Okay, so obviously this one and this one. We don't have any information to say suddenly that what we have here is 90. So I am going to extract C. Okay, that doesn't mean if you want to extract and you do this. Okay, if you extract it with the same orientation, you are wrong. Okay, you can extract them with their corresponding orientation to be the same. Only that usually I want them, all of them, to face the same direction. So if you extracted them this way, you are fine. Is that clear? It's the same triangle. Okay, the fact that the orientation has changed doesn't mean the triangle has changed. So now, solution to question number 3. Okay, right, your triangle is right here. This will also be right here. Now, what do we have? Let's look at this triangle here is QS, okay, P. So it is right at S. So I indicate my S. So the Q and P, I can put them anywhere. So let me put, P up here, and Q here for this particular one. Now, this one too is PSR. So it is, right
S.
at S. Okay, so I indicate that one first. Then, as for the PR, you can put them anyhow. So I'm going to put P here and R here. All correct, my professors?
Yes,
Yes,
please.
please.
Okay, so now, after splitting our possible right angle triangles from the major or main, diagram, you label the vertices. Then after that, what do? You go and add the extra information that possibly could be added. So now let's see. This particular one, we know that the angle at Q, here is 50. So we can add that one as well. So 50 degrees. All correct, my professors?
Yes, please.
Okay, then this one, we know the angle at R to be 30 degrees. Okay, so let me do this so that you can see that is this angle. Okay, then we also know the length of PR. Do you agree?
Yes, please.
Which is
8
8
centimeters.
centimeters. Very good. So between these two right angle triangle, left and right, which one do you think you have more meat to work on?
The one with on the right.
Okay, so the second, okay, triangle. Okay, Prof. Caroline.
Mr. Akman, please, the first right angle triangle. Please, the 50 that you wrote, it looks like 56.
Okay, so that's why I thought maybe you even say it looks like 5 theta. Okay. But in any
Yes, that
case,
one.
you know it's what 50. But if this happens to you, please, anything that you write should be clear. So make sure, okay, you make it very clear. That's the more reason why I always tell you that any diagram that you are drawing, okay, should be in pencil. Okay, so if you have this in pencil and you can easily erase and do the writing. So I am able to erase. So I have done that and I'm going to do the writing. Okay, so is it better now? Okay, all right. So now the information that we have there, we've extracted. This possibly will be our last question, looking at the time. Okay, so because we need to do a certain exercise today. All right, so this is what we have. And I guess maybe you say that my P is also looking like a D. So let me extend this. Okay, all right, so everything is clear. No ambiguities. Okay, so now let's see. You can see that unlike the first, okay, two questions that we solved, okay, where each triangle we had, okay, the one with the more materials to work on. The materials that we worked on were based on size. So we're given two sides. But here we are not given two sides. Okay, this one we are given only an angle with no side. This one an angle and one side known. Okay, and we said this will give us the one to work with because more materials here. Okay, and you can see that immediately you have this, you don't have two sides known. You cannot work with what? The particular theorem. Okay, and this one we are dealing with right angle triangle. So this should inform us that we are supposed to work with what? The trig ratios in this question. Start with the trig ratio rather than the particular theorem. You cannot apply the particular theorem here. All correct, my professors?
Yes, please.
Okay, so my questions are carefully selected for you to know each situation and how best to deal with it. Okay, given the information provided. Okay, so now this is what we have. Let's see what the question is asking us to find. The question wants us to find the length of QS. Is that not it?
Yes, please.
Okay, so the length of QS, that's what we are looking for. So we are looking for this length. All correct.
Yes, please.
Yes,
Okay,
please.
all right. So with this is what we are going to do. Okay. Remember I said anytime you have a figure and immediately you realize that the figure that you are working on, okay, you have a common side, or in this case, a common side, we come to where you have a common angle. Okay, two. If you have a common side, then the question indirectly is trying to tell you to form an equation based on the common side and solve the resultant equation for whatever that you are looking for. So if you look at this triangle, okay, the sides will be PQ, PS, and SQ. Okay, in this one too, you are going to get what? Okay, PS, PR, and SR. Okay, which side do you think will be common?
PS.
PS, do you agree, my professors?
Yes.
Okay, but no issue. Okay, I want us to approach it from this perspective before you come to. Okay, knowing from trig, you know that in this particular question, if I'm able to find PS here, I should be able to find PS. If I'm able to find PS here, it means I know this PS. And once I know this PS, I should be able to find any unknown side of this triangle. Do you agree? Because one angle and one side of a right angle, it's okay for you to find the other sides based on trig ratios and its usage. Is that clear?
Yes, please.
Yes.
Okay, so let's go by that route and see. So in this case, okay, I can find PS is the common side. So that will help me, okay, look for PS because if I know this, I can find this. So I know that, okay, if I want to find PS, PS is opposite to this angle. But the question has given me the hypotenuse. So which ratio should come to mind?
Sine.
Sine.
Yes,
My
yes,
professors,
please.
I hope you are all with me.
Yes, please.
So I will come and write from, okay, the triangle that I am working on should be clear. So which triangle? Triangle, right angle, triangle. Okay, PSR.
PSR.
Okay, so from triangle P, right angle triangle PSR, we are going to get what? Okay, sine of our angle 30.
30.
Okay, 30 degrees. Remember, I told you to come to class to get today with your calculator. So, all right, it will be equal to what? Opposite, which is what we
PS
don't know, which is the length of PS.
over 8 centimeters.
Okay, over the hypotenuse, which is 8. All correct, my professors?
Yes, please.
Okay.
Yes,
So
please.
can I say that this implies that, okay, the length of PS, because I'll cross multiply, okay, will be equal to 8 sine 30, or 8 sine 30 is equal to the length of PS.
Yes.
Yes, please.
You all
Yes,
agree.
please.
Very good. Okay. So now, okay, you use your calculator. Okay, sine 30 is half. Okay, with time you know this
Yes.
offhand. So it will be 8 times half, which will give us what? 4. Is that clear?
Yes, please.
So
Yes,
it
please.
means the length of PS is equal to 4, but we know the unit. Okay, was the unit given here? Centimeters. All correct.
Yes,
Yes,
please.
Okay, so you all agree with me that this will be 4 centimeters now.
Yes,
Yes.
please.
Okay, just
Yes.
as this is 4 centimeters that we have found. Okay, so once you have this information, you can see that finding your QS will be very easy. Okay, using this diagram. So if this is wrong, okay, everything here will be wrong as well. So in this case, I will go and pick the second triangle. So from which triangle?
From the second one, we
No,
will be using Pythagoras.
no, from the second one. Which one?
Yes,
This
please.
one.
Yes, please.
You want to use Pythagoras to find what? SR?
Yes, please.
No, you don't need SR for anything. So don't stress yourself.
Okay. Yes,
Okay,
please.
that's why I said you plan before you start. So when we plan, we realize that these two triangles, they have the same side. Okay, and I can find that common side. I can find it from this particular triangle. So if I know this, I know that. And once I know this, the question asks me to find this. So I can easily find this without finding this.
Yes, please.
You get a point now, Martin?
Yes, please.
Okay,
Thank you,
great.
sir.
All right. You are welcome. Okay, so at this point, from right angle triangle, let's go.
It's going to be
PS.
the first one.
Let's label our triangle PSQ, right?
Yes,
Yes,
please.
We are using the first one. We are going to use, so this one is the opposite to this angle. Meanwhile, the question asks us, we are looking for what? The adjacent. Is that not it?
Yes.
Yes, please.
Okay, so what would that give us? So opposite and adjacent, which trig ratio?
Time.
Tan.
8
Okay,
times, rather. Sorry.
yes, okay. All right, you put sine and tan together, don't worry. All right, so what are we going to get? We are going to get what? Tan, you said. Which angle? This time, right, will be 50 degrees. Do you agree?
Yes, please.
Yes,
Okay,
please.
and that will be equal to, we said opposite. Opposite we know is 4. Okay, but let's start with the, so it will be PS for now. Don't put the value there. Okay, all over the adjacent, and the adjacent, okay, is what? SQ or QS. Let's use, okay, so the length of QS. All correct, my professors?
Yes,
Yes,
please.
please.
Very good. So this implies that tan 50,
Tan 50 go to
50 degrees is equal to, you know, PS, and that is
4.
don't attach the centimeters. Okay, over QS, you don't know what you are looking for. All correct.
Yes, please.
Okay, so again, you cross multiply. So can I say my length of QS, okay, tan 50
It's equal to 4.
degrees is equal to 4. Do you agree?
Yes, please.
So I'm looking for QS. So I write it again, divide both sides by tan 50. All correct?
Yes, please.
Okay, so I'm going to get what? Okay, QS tan 50 again. Okay, is equal to 4. Then divide, okay, this one by tan 50. Okay, this one also by tan 50. Don't forget your degrees. So our QS here, the length, okay, will be equal to, so you can see that all along, okay, I didn't use my calculator to find tan 50 here to put its value. I'm working, okay, and because if you do that, you approximate more than once. The more you approximate, the more you move away from the actual, okay, or accurate answer. So in this case, this will be equal to 4 tan 50. At this point, you can use your calculator. Okay, so Prof. Caroline, do you want to give us the calculator value or you have a question?
Mr. Akman, please, I'm a bit confused.
Okay, where lies your confusion?
Please, when you started with the implication sign, like from that place.
Yeah.
Yes.
Okay, but you get this.
Yes, please.
Okay, then you are not confused. I will be that spirit of confusion. Okay. Okay, so let's go. What is PS?
QS.
No. Allow Caro. Caro, what is PS? What is the length of PS? Okay, from what you have done so far.
Please, 4 centimeters.
4 centimeters, so you put it there. What is the length of QS? Do you know?
No, please.
So you keep it just as you have it over there. But you are looking for QS. So remember, I told you form your trig ratio in such a way that there will be only one unknown. And obviously, you can see that after doing your possible substitution, only one unknown, which is the QS that you are looking for. So you cross multiply. So it will be this times this. So always you bring this will always be a constant. So you bring it before the tan. You don't bring it after, though multiplication is commutative. So you don't write tan 50, then you put, okay, length of QS. Bring the length first. Is that clear?
Yes, please.
Okay, so QS 50 is equal to 4. So I cross multiply. Then I wrote it again before dividing by tan 50. Because I'm looking for QS. So that this will cancel and I'll get this. You get it?
Yes, please.
So now your calculator value. You should be done, Prof. Genius.
Sir, please, I have the value, the calculator value of QS.
Okay, so let's go.
3.3563.
3.35.
3.3563.
3. Okay, so you approximated to 4 dp, is that not it?
Yes, sir.
Okay, but you know that the unit first, cm, then you indicate your approximation, 4 dp. I hope you check the next digit after your 4 dp.
Sir, please, it's supposed to be 4 because after the approximation.
Okay, read the whole of what you have there for me. 3.5,
3.356398.
Okay, so that's why I asked. So it's supposed to be 6.4. So be careful when you are approximating. That's why, okay, we taught you how to approximate. Okay, this will rather be 4. Other than that, you get the final answer mark wrong. Though you've stated the unit and indicated your approximation. So I can write therefore here. There is no required approximation, and I don't need any convenient approximation. So I have here. Alpha.
Yes, please.
Okay. Unfortunately, okay, we couldn't get to whatever that I wanted us to, learn. That's no issues. Okay, so what is important is whatever that we've done today, you have fully understood. Okay, if that is fine, then going forward, okay, the future, I know, okay, will be very bright. So at this point, I would want to say thank you very much, okay, for sticking and staying with me for your time. May the good Lord, okay, continue to bless us all.